Hi everyone, in this video I'd like to talk about recurrence relations. So to get us started thinking about what these are, I'd like to start off right with an example. So let's suppose you make $1 on day one, $2 on day two, $4 on day three, etc. They want us to write a recurrence relation. So I'm going to start off here and just make a little table so that I really understand what's going on. So let's let n be the day that we're on. So we can have day one, day two, day three, and maybe we can even figure out the pattern, day four, day five, etc. And then this is how much money. So I'm going to call it the amount of money in my second column. So I know on day one, I earn $1. On day two, it's $2. On day three, it's $4. And so I'm looking at the pattern. It looks like I'm doubling. It looks like I'm doubling my salary every day. And I really wish this was my job because I'd be really quite wealthy. So it's not the case, but let's continue the pattern here. So if I double again, if I double the 4, I multiply by 2, I'm going to get to 8. And then on day 5, I'd be up to $16, etc. And so if I have just in general the amount that I make as a function of n, my day number, it would be, well, what would it be? It would be 2 times the amount I made on the previous day. So let's write this in words. This is 2 times the amount made on the previous day. So for example, if I wanted, A of 4, the amount on day 4, n is 4 in this notation, what I need to do is take 2 times the amount that I made on 4 minus 1. I need to do 2 times the amount made on the third day. And that's exactly the pattern we saw over here. Right? You take 2 times the amount made on the third day. So the amount made on the third day was $4. And that's why we figured out we got $8 on the fourth day. So this idea of a recurrence relation, this notation A of n minus 1 means the amount made on the previous day. Sometimes you'll see slightly different notations. Sometimes you'll see this written as a recursive sequence. So you'll see A sub n as a subscript equals 2 times A sub n minus 1. And again, that means the same thing. It's 2 times the previous term. Let's do a few more examples so we can see how this works, because the idea in the math, the arithmetic, is not the hard part. The hard part is diving through all the notation. So I'd like to do another example. So for example 2, we're given a recurrence relation. It looks very complicated, but it's actually not too bad once we get into it. And this is sometimes given as a bunny model, a rabbit model, and you're supposed to determine when the rabbits die and things like that, which is kind of sad. But let's start off here. The first line of our post, and I'm just going to read right here on this first line. It says g of n, in other words, the value of g equals 0 if n is less than or equal to 0. So let's make a chart here. And then I'll put my g values in the next column. I can call it g of n if I want to. So this means that all sorts of things, like if I started at negative 10 and negative 9, I'm just starting way out there for good measure, so I'm not leaving anybody out. All these negative values, it says if n is less than or equal to 0, my value in the sequence, or the value in the recurrence relation, is going to be 0. Nothing's happening yet. And let's continue our chart on. I'm going to loop over here, so I'm going to keep going. I've got -4, -3, -2, -1, 0, 1. Okay, I know if n is less than or equal to 0, my value is still going to be 0. Nothing exciting is happening. Now, let's move down here to the next line. It says if n equals 1 or 2, the value is going to be 1. All right, so far so good. We'll keep going with our table of values. If I had a big sheet of paper, I could work down my page. 3, 4, 5, 6, 7, 8, etc. But let's keep going here. When n is 2, the value is still going to be 1. All right, now let's move on to the third line of the formula, which says if n is greater than or equal to 2, like in this case that n equals 3, I've got to crank through this formula. So let's do those calculations. N equals 3. So I want to know g of 3. And my formula says that I have to plug in g of n minus 1, which in this case is 3 minus 1, plus g of n minus 2, which is 3 minus 2, minus g of 3 minus 8. All right, so let's work inside our parentheses here. I'm going to work down the page. I'm not going to leave anybody out. I've got g of 2 plus g of 1 minus g of 3 minus 8 would give me a -5. Let's go hunting for those values. G of 2 is in my chart, and it's right here. When n is 2, the g value is 1. So I'm going to put that right there. G of 1, when n is 1, my g of n, or my g of 1 is 1. And I need minus g of -5. And when n is -5, my g value is 0. So this tells me that g of 3 equals 1 plus 1 equals 2. Let's do one more. This might be a good place to pause the video to see how you're doing with the formula. So if you want to pause the video and come back and check the answer, you're welcome to do that. Okay, so when n equals 4, I'm getting a value of 3. And you can keep on going with this calculation. And what you'll notice is that this last term here, the g of n minus 8, just put a little squiggly around it, this is going to be 0 for a long time. In fact, it's going to be 0 until you get to a point where like n equals 9 or something like that, because 9 minus 8 is going to be 1, and that's going to start picking up some values. So if you want to think about when your rabbits are going to die, my recommendation is crank through your chart a little bit longer, and you'll probably see some place in here where the death term starts to kick in. This is your death term. I know that sounds terrible, but at some point rabbits will start to die, and then you will start to see a pattern of how many years they might be living. I don't want to give answers away. I do want you to think about it, but I think that's a very good hint if you continue your table a little bit farther.